right, we're going to go over the assessment practice. So this is to get you ready for your common assessment quiz. All right, it says data collected. A group of students stood 30 meters from the base of a radio tower and measured the angle of elevation to its top of 72 degrees. All right, so first thing we're asked to do is create a diagram of the scenario. So make sure you read carefully. There's a difference between angle of elevation versus angle of depression. So here is our little radio tower. So we'll use a little straight line. I'll go ahead and draw my horizontal. All right, so here's where my students are going to be standing. All right, it says they stood 30 meters from the base of the radio tower. So here's my students, here's my radio tower. 30 meters means the distance between these two is going to be 30. The angle of elevation to its top was 72 degrees. So remember, an angle of elevation goes out the horizontal and then up. So there's our angle of elevation, which is given to be 72 degrees. All right, also be very mindful, degrees versus radians. You don't want to get the two mixed up because that's going to change what we have to do. So make sure we put our little degree symbol so we remember that this is in degrees. All right, so here's our little diagram. Use a trigonometric function to estimate the height of the radio tower, round to 1 digit. So the height of the radio tower is going to be this length over here, and I'm going to use an h to represent its height. All right, so if I'm looking at this diagram based on the given angle here, based on the given angle, I know one of the legs, and I am looking for the other leg. So the trig function we want to use that involves the legs is going to be tangent. So the relationship here is tangent of the angle, which is 72 degrees, is going to be equal to the ratio of the opposite leg, h, to the horizontal or the adjacent leg, 30. So here's our relationship. So if we solve for h, we would multiply both sides by 30. So I'm going to get 30 times the tangent of 72 degrees equals h. All right, so we have our formula. Now we just need to go to our calculator. However, be very, very careful with your calculator. Default mode on your calculator is always in radian. So I'm going to hit my mode button. Notice I am in radian mode, so I need to go down to radian, over to degrees, and I need to push enter. Oh, come on, calculator. There we go. Enter. If you don't change your mode, you're going to get a very, very different answer. All right, so I'm going to do 30 times tangent 72, close my parentheses and hit enter. So our height is going to be 92.330 ... and then I'm going to go reread to make sure I answer the question correctly. All right, so estimate the height of the radio tower, round to 1 digit. So to 1 digit, my height of the tower is 92.3, and then go check my units, meters. So again, I said be very careful if you're in the wrong mode. So I'm going to go change my mode back to radians, and I'm going to recalculate just to show you. So exact same thing typed in. However, I get a very, very different answer, not even a logical answer in this case. So be very mindful that you are in the correct mode. If your angle's in degrees, make sure your mode is in degrees. If your angle is in radians, make sure your mode is in radians. All right, next question. If the distance from the base is 80 meters and the height is 74.6 meters, what is the angle of elevation in degrees and radians? All right, so we're asked for two things, 1 degree answer, 1 radian answer. So we have new measurements, so I'm going to redraw my picture. The height is 74.6. All right, come on. Well, that is not what I drew, but close enough. All right, 74.6 is my height. The distance from the base is 80. So here's where my students are going to be. Here's my radio tower. This is 80. What is the angle of elevation? So again, angle of elevation out a horizontal and up. So here is our angle of elevation, which I'm going to label as theta, since it's an angle. You could use whatever variable you would like in this case. All right, so as far as relationship goes, again, I know information about both legs, and I am looking for the angle. So the trig function that involves both legs is still tangent. So our setup is going to be tangent of our angle theta is equal to the ratio of the opposite leg, which is 74.6, to the adjacent leg, which was 80. So here is our equation. As far as solving, remember to get the angle by herself. Theta, we use inverse tangent. So theta is going to be the inverse tangent of the ratio 74.6 divided by 80. All right, so here's our formula. Now, we just need to be very careful that we are in the correct mode. So we were asked for two answers here, one in degrees, one in radians. So let me go, I'm going to stick with degrees first. All right, I'm in degree mode, so quit. So I'm going to go second tangent, that gets me my inverse tangent. Alpha y equals is my shortcut for my fraction template. 74.6 divided by 80, close my parentheses. So we have, let's see, 42.9999. All right, so theta is 42.999 dot dot dot. I'm gonna go ahead and put my degree symbol. All right, if I go reread, round to 2 digits. So to 2 digits, that 9 is gonna force, the 9 also forces. So to 2 digits, our answer would be 43.00 degrees. All right, as far as radians go, let's go. I'm just going to change my mode. So you actually could do this two ways. You can either just change your mode, or you could just convert it. So I'm going to change my mode. All right, second quit. And then I can just retype. And I've got 0.75. So theta is 0.75. And normally when we do radians are technically unitless, but I like to put rads at the back just to remind myself that it is in that mode. All right, second option, instead of just going back to the calculator, and I normally won't go back to the calculator, I'll just convert it. So there's my degree answer. So my theta in radians would be 43 degrees, and then we use our conversion pi over 180. So our degrees divide out. And then we would do 43 times, and I go get my fraction template again, alpha y equals pi over 180. So see, we get our same answer to 2 decimal places. 0, whoops, I guess I don't have room to go right there. We'll erase that right there. And then we would just go and give our answer here. So either way, convert it in the calculator or use your shortcut. All right, make sure you get that common assessment completed and uploaded to Canvas before the end of the week. Let me know if you have any questions.